Okay, so get your handy dandy calculators out. Go ahead and clear out. Make sure your plot is on, clear out any equations. And then go ahead and go to lists and clear those out if you have any numbers there. And then get it all set up. Okay, all right. This table shows the U.S. Bureau of Census population data for St. Louis, Missouri. It's that. Okay, so we have a table. So we know the top one's the variable, which in our calculator is X. The bottom one is the function, which in our calculator is Y. And then we know that the variable always coordinates with list 1 and the function list 2. Okay. All right. I also noticed that this says years since 1950. So these are already set up. Okay. So you don't have to make any adjustments to this. I did have a handful on the quiz make adjustments on a table that it was not necessary to. The only time you have to do that is if these numbers are years, like 1950, 1960, 1970, or if they're time on a clock, 12 o'clock, 12:30, 1. But if they're numbers other than that, you just leave them alone. Okay. All right. So it says plot the data points. So I know I'm going to have to enter these in my table. So it's stat 1, and then go ahead and enter your list 1 and your list 2. And you need to be to a point where you can do this pretty quickly, because you don't want to have to be trying to figure this out on the test. This should be something that goes quickly on the test so you don't run out of time. So if you're not good with the calculator part yet, then you need to be doing that over and over and over till you are, so you're not wasting valuable time on test day because of calculator, not knowing how to manipulate your calculator. All right, so once we get list 1 and list 2 in, where do we go? Zoom 9. Now it should look like this. If yours does not, let me know and let's see if we can figure it out. Okay, so we're going to plot that. Now, anytime you're asked to plot, you should know by now I'm going to grade that your axes are labeled. So the vertical is our population, which is P population. And this is in thousands. And then my variable is T years since 1950. And another area to be careful. When I look at my table, I know this gives me 1, 2, 3, 4, 5 ordered pairs. So when I look over here, I only see 4. Where's the 5th? It's up here on the vertical axis. So don't neglect it because you're not paying attention. So it's up here. Here. So it kind of looks like that. Okay. All right. Find the equation. Now what you need to watch for is the regression line. So this tells me that it's not a true linear relationship. So we're not going to prove or show using the average rate of change. This is when we use the calculator. Okay, so we have our list 1 and list 2 already in. So where do I go to find the information I need on my calculator? Okay, so stat which is here, and then you're going to right cursor over to calc. And then you're going to choose 4. And then be sure it says list 1 and list 2, and then just enter, calculate till you get to enter. And then what you need to remember then is that A is your slope. And since I don't see that it says anywhere how far to go, I'm going to go 3 decimal places. Negative 11.389. All right, y'all, this means this is the slope, right? Does that make sense with my plotted graph? If we were to draw a line, would the line not go down? It would, which represents a negative slope. So this makes sense. Okay. So then we get B, which is 844.638. Now, what is B? The initial value. So here's where I want to show you. This is how I know that this is the line of best fit, that we don't have a true linear. Look up at your table. If we had a true linear relationship, what would the initial value be? The variable 0, it would be 857,000. That's not what we got. And that's because it has a line of best fit, not that every point is on the line. All right, so I'm going to write the equation, which comes from y equals mx plus b. Y is my function, and I look up to my table and I see that the function letter they're using is p. We just found m, the slope, to be negative 11.389. And then the whoops, not x. What am I going to use? T. I can make that x a t for time since 1950. And then my initial value is positive, so plus 844.638. Now, in my last class at 9:30, I neglected to do this. I'm not going to neglect to do it in here. I did not notice that it said and add the graph. All right, so where do we go put this? Okay, so I'm going to go to y equals negative 11.389x plus 844.638. And then what? Graph. So I'm going to go ahead and add that. Which would be like that. You can tell mine's not exact because it goes through that second one. Mine wasn't, but that's okay as long as it's kind of close. Okay. All right. Now we didn't do this on the quiz. We did an average rate of change. And then the next question said, explain in practical terms the meaning of the slope. Well, it first asked, what is the slope? Well, on your quiz, it was what you had just calculated, but it was like students thought I have to come up with a different number. In this case, we didn't have to calculate it, but we got it from the calculator. So I'm going to write it over 1. And then before I do my explain, I'm going to make sure that I understand what each represents. So what is always in the numerator on your slope? It's the change in what? Function over the change in variable. So that means this negative 11.389 goes with function that is population in thousands, because I have some that are still getting that backwards. And this would be per one, what? Year. All right. So now that I took the time to do that, it makes the explain hopefully a little bit easier. So we're always explaining the function. And in this case, the function is the population, right? So the population And it's actually the population for St. Louis, Missouri. Now, on the test, if you said the population, but you didn't include St. Louis, I might write it in there, but I probably wouldn't count off because you at least put the word population in there. Okay, what is the population doing? Okay, because it's negative, it tells us that it is decreasing, which makes sense in relationship to our plot. And it's decreasing negative 11.389 thousand per 1 year or per year. Now, you could have written this as 11,389, which would be, whoops, y'all, what did I do wrong? I just caught it. Don't put that negative. That was taken care of in the word decreasing. So if you put a negative there, erase it. Sorry. It's decreasing 11.389 thousand, or you could have written 11,389. 11,389 means the same thing. Okay. Man, I'm glad I got that. All right. Estimate the population for St. Louis in the year 2002. We were given variable value. All right. So my variable is T. Does T equal 2002? Is that what I'm going to substitute into? No, it's since when? Since 1950. So we're talking about 52 years since 1950. So my variable is 52, not 2002. All right. So if I asked you to write that in functional notation, what would that be? P at 52, which means the population 52 years after 1950, which is the population of 2002, is, and then we come up here to the equation that we found, and we're going to substitute it in. Now, please wrap in your head that this population is decreasing. So notice how it's getting smaller and smaller. So if I calculate 951,000, that doesn't make sense, right? I'm hoping that's not what you calculated. What'd you count? Give me 2 decimal places.
252.41,000.
Whoops, thousand. Or you could have written it as 252,410. Those mean the same thing. But I would keep it like this, mainly because that's the verbiage in the problem, plus you'll see why here on part E. All right, how many years will it take the population of St. Louis to drop to 200,000? All right, what's given? Okay, so we're given function value. All right, now here's where you're going to need to be careful. Here's what we were given. So when I go back to my equation, P equals negative 11.389 T plus 844.638. Does anybody know why I don't want to put the number 200,000 right there? Oh, question? We're done. Okay, thank you for coming and taking that. Appreciate it. Okay, so notice that this is 200,000, whereas these are like 844.638 thousand. So we need to write this as 200,000. So it matches up to the numbers that are in the equation. So in place of P, you're going to put 200. because that does represent 200,000. Okay. All right. So then what we're gonna do is solve for T. We need to move 844.638. It's being added, so we're gonna subtract it. Which gives me negative 644.638 equals negative 11.389 T. And now to undo that multiplication, we divide. So we're going to divide by a negative 11.389 on both sides. And here's what happens. We're talking about population. Well, what's negative divided by negative? Positive. So it all works out. Give me that to 3 decimal places. Now it said how many years? We just told them how many years. It didn't ask in what year. In what year, then we would have added this to 1950. But it just said in how many years, okay? All right, so that finishes up 3.4. Don't forget that is due tonight. All right. 3.5 is what we call systems of equations. Notice equations is plural. So we're going to be working with more than one equation at a time. All right. So a system of linear equations is a set of 2 or more linear equations. We're always going to be dealing with 2. If you take algebra for STEM, you will also deal with 3 equations. Okay, but we're just going to stick to 2. The solution to a system of 2 linear equations, you can check it algebraically, and that is where an ordered pair satisfies both equations. You can also look at it graphically, and that is where there is an ordered pair where the line intersects. Okay, I wanted to give you guys a visual of this. So I have actually I graphed 2 equations in this is called Desmos. And so I have a red equation and I have a blue equation. Okay, so on the red line, every dot on this line would represent an ordered pair that is on that line. Okay, so like if I chose this point right here, that is negative 6, 5. Notice how it falls on that red line. So what that means is if I put this ordered pair into this equation, it would satisfy that equation algebraically. So 2 times negative 6. So 2 times negative 6 is negative 12. Plus 3 times 5 is 15. Well, what's negative 12 plus 15? 3. So it algebraically satisfies that equation. I could choose another point. Let's see, this is 0, 1. It graphically satisfies this because it falls on the line. Algebraically, if I put 2 times 0 is 0 plus 3 times 1 is 3, 0 plus 3 is 3. So algebraically, it satisfies that particular equation. Okay, we can look at the blue line here. Let's see, 6, 2 is an ordered pair. Oops, then 5. Notice it graphically satisfies that second equation because it falls on the line. If I substituted 6 in for X and 2 in for Y, 6 minus 2 is 4, it satisfies it algebraically, okay? So what it goes on to say is that if you notice that second bullet point says there's an ordered pair where the lines intersect. So right here, when it points up and it shows you, that is an ordered pair that falls on both equations. So it means graphically they intersect. And then if we would take that 0.3 negative 1 and plug it both back into both equations, it would satisfy it algebraically. Okay, so you know the answer. I just showed it to you, but we're going to learn how to find the answer. So I'm going to go back to here. So we already know what the ordered pair is. We're going to look at 3 different ways to find that ordered pair, because you're not going to have the ability to use Desmos. That's not part of this class. Okay, so the first method is what we call the substitution method. And it's just that. We're going to substitute something for something else. Okay. All right. So I'm going to call this equation 1. And I'm going to call this equation 2. Okay. Just so you can follow what I'm doing. All right. It says solve one, not both. Solve one of the equations for one of the variables. So what it is telling us to do is choose one of the 2 equations and solve for either X. So it says X equals something, or you can solve it for Y. So it says Y equals something. Okay. You can choose either equation. You can choose either variable. As long as you do all your steps correct, you'll get the same answer. But I'm going to give you a hint on what to watch for. Look at the coefficient in front of the variable. Look at the number in front of the variable. That's what a coefficient is. If any of them have a coefficient of 1, that's the equation and the variable that you want to choose. It's a whole lot less work. Okay? So I look at equation 1, this has a coefficient of 2 and this has a coefficient of 3. I would like to avoid that equation if possible. I come down here to equation 2, this has a coefficient of positive 1, this has a coefficient of negative 1. So they both have a coefficient of 1, it's just one of them is positive and one of them is negative. It's easier if you choose the one that's positive. Okay, so I'm going to choose this equation right here. So I am going to take equation 2 and we are going to solve that equation for X. All right, so I'm going to rewrite it. X minus Y equals 4, and I want to solve for X, which means I want to get the X by itself. How do we move the minus Y? We do its opposite, which is add. We're going to add Y. So now I'm left with X equals 4 plus Y. This equation and this equation are still the same equation. They're just, they look a little different. Okay. All right, so that's the first step. Then it says, substitute this into the other equation. So since we chose equation 2, I now have to go to equation 1, which is 2x plus 3y equals 3. Had I chosen equation 1 here, then this one would be equation 2. So always go to the other equation. All right, now here's where the word substitution comes in. X is equivalent to this right here. So I'm going to substitute that in for this X. So instead of 2 times x, now I'm gonna have 2 times, what am I gonna substitute for x? 4 plus y. So this is the same thing as x. And then we still have the plus 3y equals 3. All right, everybody with me? Does anybody have any questions? Okay, so now what we're gonna do is solve for the remaining variable. So now we need to solve this for y. Okay, be careful. Notice how we have a whole bunch of stuff on the left side. So what we want to do is be sure that left side is completely simplified first. Don't start moving things yet. So the first thing that we're going to do is distribute this 2 through. 2 times 4 is 8, plus 2 times y is 2y. Then we still have the plus 3y, and we have the 3. Now, we always want the variable to be on the same side. Notice it's already there. I do not have to move my 2y. I do not have to move my 3y. They're already both on the left side. So all I have to do is combine those like terms. Well, if you have 2 y's and you add 3 more y's, how many total do we have? 5. So we have this 8 plus 5y, and we still have equals 3. All right, so if I'm solving for y, I now need to move this 8. How do we do that? We're going to subtract it. So now I have 5y equals 3 minus 8. If you're not comfortable with your ability to do positive and negative numbers, let your calculator do it. It's -5. And then we're going to divide both sides by that +5. And so we're left with y equals -5 divided by 5 is -1. So ultimately, we know we're looking for the ordered pair that satisfies both of them. We know the first is your x value, the second number is your y value, and we just found y to be -1. All right. Now substitute again to solve for the other variable. What it wants me to do is we now need to find x, because we now know that y equals -1. So go back to one of the 2 original equations. It doesn't matter. Since these intersect, that ordered pair satisfies both equations. So you can choose the first equation or the second. Just because the second looks to have fewer numbers and maybe less work, I'm going to choose x minus y equals 4, and in place of y, I'm going to put -1. So I have x minus -1 equals 4. Now, be careful. Does anybody remember what's minus negative the same as? It's plus. So this actually means x plus 1 equals 4. And so we need to move this 1 by subtracting it. So we get x equals 3. X equals 3. That means this point satisfies this system of equations. So on the graph, it's where they intersect. And didn't we see that? Even when I did my cursor over, it showed us this answer, correct? So graphically, it's where they intersected. Algebraically, it means that it would satisfy both of these equations. So if I substitute the 3 in for x and the -1 in for y, so 2 times 3 plus 3 times -1, it should equal 3. It does. When I do 3 minus, and then the y is -1, that should equal 4, and it does. So it satisfies both equations algebraically as well. Okay, all right, that's a substitution method. Any questions? Okay. Method number 2 is what we call the elimination method. And guess what? We're going to be eliminating something. Hence the name. All right, so ultimately what we want to do is we want to be able to eliminate the variable x, or we want to eliminate the variable y. And in order to eliminate it, we need their coefficients, the numbers in front, to be opposites. Okay, so this is a 2x. If I wanted to eliminate my x's, I would need this coefficient to be what? Negative 2x, because we're going to eventually add, and what do you get when you add opposites? 0. So that would eliminate the x's. Now, I'm not going to choose this. I'm just going to choose something random. Let's say that I had my y coefficient was negative 5y or minus 5y. What would be its opposite? Positive 5y or just 5y, because when you add a term with its opposite, it always gives you 0, which would then be eliminated. Okay? All right. So here's my hint when you are choosing how to eliminate either the x's or the y's. Look at both equations and ask yourself, do either of the variables already have the same number in front? Like a 2 and a 2 or a 3 and a 3? And they don't, right? So then I would ask myself, do either of them already have opposite signs? Well, this is positive and positive, this is positive and negative. So my y variable is already opposite signs, right? Okay, so I'm going to eliminate the y's. So here's how we do that. So I'm looking at my y's. This is 3y. What would this need to be in order for me to eliminate my y's? Negative 3y, right? Now it's already negative. What would I have to do in order to make it negative 3y? Not add it, because y plus 3 is y plus 3. Multiply, okay? All right, so what that means is I am going to multiply the second equation by 3. Now, since my first equation already has this positive 3y, I don't have to do anything to the first equation, so I'm not going to write anything there, and I'm just going to rewrite it over here. Now, here's the big thing. You don't just multiply this term by 3. If you're going to multiply by 3, you have to multiply the whole equation by 3. Which means every term changes. X times 3, 3x. Negative y times 3, minus 3y. 4 times 3, 12. Now what we're going to do is we are going to add these two equations. 2x plus 3x, well, now how many of them do I have? I now have 5 x's. These are opposites, and when we add opposites, what does it give us? 0. So that would be plus 0, and then 3 plus 12 is 15. So technically what I have left is 5x equals 15. Oh, well, I can solve that pretty easily. Undo multiplication by dividing. And we get x equal 3. Okay, well, we already know that, don't we? Because this is the same two equations. So I know so far, so good. Now what we need to do is find y by substituting x equals 3 into one of the two original equations. It doesn't matter which one. So last time I used the second equation, this time I'm going to use the first one. So 2x plus, well, I meant to put that in there, but I'll just rewrite the equation. All right, so in place of x, we're going to put 3. So 2 times 3 plus 3 times y equals 3, which is 6 plus 3y equals 3. Now I need to solve for y, so we're going to move that 6 over by subtracting 6. So now I'm left with 3y equals 3 minus 6 is -3. Divide both sides by 3, and I get y equals -1, which we know to be the correct y value. So using the elimination method, we got the exact same answer. Okay. All right, we've got one more method and then we're going to call it a day. This is the third
When we're
method.
doing this on the test, can we choose it, or are you gonna make us pick a certain one?
Right now, the test will say use this method. So as of right now, that's what it says. When we get where we'll review, I'll let you know for sure. Because I was just thinking about that very same thing this morning. So I don't know if I'm going to alter it yet or not. Okay, so the third method is the cross graphs method. All right, what do you think we're going to do? We're going to graph, so we're going to use our calculator, right? We're going to use our calculator. How many equations do we have? 2. So ultimately, we're going to put in a y1 equation and a y2 equation. But in order to put it into my calculator, first, what has to be true about my equations? Because I can't go in and put these in here right now. They have to be solved for y. So notice, solve each equation for y. So let's take equation 1, which is 2x plus 3y equals 3. And I'm going to solve for y. Okay, so that means I need to move 2x to the other side. How do I move this 2x? I'm going to subtract it. So I'm left with 3y equals 3 minus 2x, because those aren't like terms, so you cannot get 1x, okay? And then to undo that multiplication, we divide by 3. So I get y equals 3 minus 2x over 3. Now, if you wanted to go ahead and put that 3 over 3 minus 2x over 3 and get 1 minus 2/3 x, it means the same thing. But I think a lot of y'all are just, let me just put this in and I'm okay with that. Okay, so we're going to leave that alone. So now we're going to go to equation 2, which is x minus y equals 4. And again, we solve for y. So I need to move this x by subtracting it, and I get negative y equals 4 minus x. Now, I'm not done. I have the y by itself, but I don't want that negative in front. So we're going to divide both sides by -1. Negative divided by negative is positive. So now I get y equals. Now, if you put that into your calculator, it would accept it. But y'all, when you divide by -1, all that does is changes every sign of each term in the numerator. So that 4 would become -4, and this minus x would become plus x. So this is what I want to put into my calculator in the Y1 equals. And this is what I want to put into my calculator for the Y2 equals. Okay, so I'm going to do that. Now we had a little problem in my first class. Let's see if it happens here. Okay, so alpha y equals 1, 3 minus 2x over 3. Y2 is -4. Do -4, not -4. -4 plus x. Okay, so before I graph, it talks about up here, find a window. I'm gonna push window, but I'm gonna leave it alone. And I'll tell you when some adjustments might have to be made, but I'm just gonna see if we're good. All right, what do I hit now to actually see the graph? Zoom 0. All right, did it work or did I get some that got an error?
Not an error.
Got an error? Why did mine work and yours didn't? Okay, here's what we did. Go in to make sure everything's out of your list.
You gotta turn off the plots.
That was one of the other things, but we did that first, the first step I did, and it still didn't work. Because I had my plot on. And it worked. So, but go up and turn your plot off. Now, okay, we may have to do one more thing, but go ahead and hit Zoom 0 now. And did you get it, or are you still getting an error? Error. Okay. Go to window. Leave X min at -4.4. Do the X maximum. So what is our X value where they intersect? 3. So I'm going to do an X max of 10. I want it bigger than 3. So I'm just going to choose 10. Leave that 1. Y minimum. Okay, well, what is our Y value? -1. I'm going to put this in as -10. And go ahead and change the Y max to +10. Now do Zoom 0 and see if your calculator likes it better. Anybody error? You still have an error? Okay, still getting an error. I want you to stay after class so I can look at it. I don't know why. Okay, all right, but pay attention because we're not done. We have a picture of it, but I've not yet found the intersection. How do we find the intersection? All right, so go to second calc. So second, and it's up here above the word trace, calc. And what do we choose? 5. Now remember, it says first curve, hit enter. Second curve, hit enter. Third curve, hit enter. Intersection, notice it gives you that X equals 3, Y equals -1. So you get 3, -1. Okay. All right, so I'm getting ready to turn Zoom off, and if you get an error, what we did in my first class was we just took everything out, turned it off, and then back on. So I'm just letting if my Zoom people have that problem.